Welcome everyone. My name is Jenny Eber. I am the constituent coordinator for Phius, and I am so excited to invite you to our Phius Prescriptive Path 2021. We'll turn it over to our wonderful team. James, take it away. You're on mute, James.
Thanks, Jenny. Graham and I are going to head this together, and I will actually defer this to Graham to start.
Okay, welcome everyone. Let's get that CEU slide up there. Great. Okay, so yeah, we've got a lot to cover here. So please put the questions in the chat. Lisa is answering questions there, and we'll try to have time for some Q&A at the end, but if we don't, we will try and follow up with unanswered questions. Go ahead. All right, so as a preamble here, we expect that the way that you'll engage with the prescriptive path after you're familiar with it is to start with the snapshot. And this is an online tool that gives you a readout of the prescriptive path requirements that vary by building or by climate. So you put in the climate location and a few basic things about the building up at the top, and it gives you a list of the requirements that, like I say, vary, but there's a lot of requirements that don't vary. So we're going to go through those also. So after a little bit of background, we're going to go through our prescriptive checklist section by section. Then we'll kind of review a summary of updates that we made based on the public comment and talk a bit about the process. Okay, so what the Phius Passive Building Standard does is it requires design for low heating and cooling loads, requires design for low energy use overall, and requires quality construction. And we want the Phius prescriptive path to continue to do all these things. But we think it's time to get going on scale up. The tagline we chose for 2021 was emissions down, scale up. Emissions down has a lot to do with electrification friendly or fossil fuel unfriendly provisions that we put in. But the scale up is mostly about this prescriptive path. And we think it's time that that the CPHCs with their energy modeling skills maybe have better things to work on than routine single family houses. Maybe just the fancy single family houses or larger projects. Go ahead. Okay, so we've been regulating the heating and cooling loads with performance targets. And it's not a huge mystery of what causes heating and cooling loads. It's, heat transmission loss, ventilation loss. And so on this prescriptive path, instead of regulating the overall performance, we're regulating these elements that cause the heating and cooling loads piece by piece. So the numbers under the along the bottom there are the numbers of the sections in the checklist that pertain to these different elements. But in addition to the passive measures, we also, of course, still want to address the overall energy use. So there's also, as you see in box 9 there, regulations on having to do with lighting, appliances, and hot water. And also in box 1 there, we have some scope limitations to reduce the risk. And that general scope is applying to single family as defined by Energy Star, that's attached or detached. The scope is restricted to houses that aren't too big in terms of the square footage per bedroom. And we're going to just say no fossil fuel combustion. That's also an overall energy measure or electrification friendly measure. We're going to avoid the risk of any indoor pools or jetted tubs or any natural draft fireplaces. Okay, very important to note that this is like our other programs or other certification paths built on Energy Star, DOE Zero Energy Ready Home, and EPA Indoor Air Plus. And so the checklist that we've come up with adds just a few more pages to that. And the administration or the verification of those prerequisite or co-requisite requirements has been done by the raters and will continue to be done by the raters. And all three of those programs that we require have already been consolidated into the Phius Quality Control Workbook for Single Family Projects. And yeah, in my mind, having the rater on board early is, a rater would be an ideal submitter for a prescriptive path project. Go ahead.
Right.
Okay.
And now we're going to dive into the piece by piece of the checklist, starting with airtightness as the first passive measure. So the high-level things for airtightness that are different in the prescriptive path than typical are that the airtightness requirement is tightened. It is 0.04 CFM, 50 per square foot of enclosure area. And this was basically implemented as a cost-effective strategy. And we're trying to match the prescriptive path with what we were seeing in the performance path modeling and improve the energy efficiency of the projects. And many projects that we've seen go through the certification process so far have performed at this level. So we felt it was a reasonable ask. And then on top of this tighter air tightness, we are also requiring a preliminary blower door test. So this is a recommendation in the performance path, but for the prescriptive path, it is now required. And the idea here is to reduce risk and increase the success for less experienced project teams.
You don't have to pass the criterion at that point, but
right. But you do need to
where your leaks are. Yeah,
exactly. Right. And preliminary blower door test here basically means a blower door test is conducted before finishes go up so that you can come around and find leaks and address them before you've got drywall up. The last part that we've got here is detailing is required for Phius's review of a prescriptive path. And this is in general to reduce risk. But we do have a specific line item that says that detailed drawings must be comprehensible and show a continuous uninterrupted air barrier that forms from different materials and components at all junctions. And I've got a couple example images of what we're looking to see here for this kind of stuff. So this is already on the Phius website. This is the Phius sample project that we've got up for review. And this is basically distinguishing with color coding the different thermal control, water control, vapor and air control layers. So this is one method of showing how you're keeping that airtight boundary continuous. And then another example we've got here is from the Building Science Corporation, where they have different call out system for detailing rather than color coding with the line differentiation. I think Graham is preferential to this one because it does go into quite a bit more detail of how these different components attach to each other. But I think they would both be acceptable ways to provide detailing and ensure successful air sealing.
All right. And this is just a requirement that's carried over from a performance path, or right. Go ahead.
Exactly. Yep. And so next section in the list after air tightness is compactness. This was something that we did address quite a bit after the public comment. So in general, we are trying to prevent egregious cases of non-compactness or very spread out houses. And when we were testing the prescriptive requirements on past certified projects. So we basically looked at old energy models and we updated them to have the prescriptive R values and window U values, et cetera. We found several projects that were underperforming in terms of their performance, even after putting those prescriptive requirements. And many of those had in common with them that they were non-compact by our definition. So we basically said, we're gonna try and fix this. And we pretty much pushed away our first attempt at trying to define compactness and went with a hopefully much simplified option for people to look into. So the new rule for compactness, which is now directly built into the prescriptive calculator, is that basically we are creating a notional compact building based on the provided ICFA and the number of walkable levels. So this notional building assumes an evenly distributed ICFA per level. It assumes 12 feet of building height per story, and then it adapts width to depth ratio of 3 to 1. So in this case, we're showing an example project that was a performance path project from a few years ago. If it's not completely obvious to you on first glance that this is a pretty non-compact building, maybe the image below it, which is the notional building based on this building of being a compact structure, will kind of point you in the direction that Phius is trying to get buildings to look. So the rule here is that the proposed building enclosure surface area is not to exceed this notional building. And again, the calculator does this for you and basically calculates the square footage that you are not allowed to exceed. And that's basically the rule for compactness that we've simplified down to.
All right, so this protects against things that have either too much envelope area or too little floor area. Okay, and I think I'm doing solar protection, is that right? Okay, section 4 is solar protection. Next slide. So there are, so we start off, we have a limit on the overall window to wall ratio of 18%. This is the performance path study buildings that we used for standard setting had 15%. So we backed it off a little bit for the prescriptive path. South overhangs are required in certain climates. And the projection factor varies based on the latitude. And there are limits on the solar heat gain coefficient of the windows, which parallel the ZERH requirements. In addition, we have rules about the fenestration orientation. That's the distribution of the windows on different sides of the building. And there are two aspects to that. One is looking at avoiding too much cooling, so preventing a high peak cooling load. And the other is trying to avoid a large net loss in the winter. So we looked into, so we did a study on this adequate exposure diversity concept. So that's a concept that we got from Manuel J. And that looks basically at the ratio of the peak hour glass load to the daytime average. And we studied it though in Energy Plus, and we ran simulations that looked at a few weeks around the summer solstice and a few weeks around the equinox. And we did a whole bunch of combinations. So we looked at that in every climate zone, all 19 climate zones. And in each climate zone, we looked at 15 different fenestration orientation configurations. So there's a list of them there in the upper left. And you can see what's going on is that like in the pink ones there, we've got like 100% of the windows concentrated on different sides of the building. The blue ones have like a third of the windows concentrated on 3 of the sides and then nothing on the 4th one. And then there's a bunch of 50-50 combinations as well. So we looked at all combinations of those in 19 climate zones. And what sort of came out of that, as you can kind of see in the lower right, is that having a high maximum concentration, like in any direction, was generally bad, except that it did interact, like it mattered which direction that was. So the worst points were when you've concentrated everything on the east or the west. Concentrating everything on the north wasn't so bad. Concentrating everything on the south wasn't so bad. So we made basically zone by zone regression fits to this data, and then we set a limit at the median or at the mean level over the orientation configurations. We did that zone by zone, and then we normalized it again to be like a 0 to 100% scale for all the zones. And so the way that this works in the checklist is that you've actually got 3 options. So all of this is based on a concept of this adequate exposure diversity. And so you can follow the manual J rule that says, well, if you just have a window to floor area ratio left at less than 15%, you're good to go. Or if you want to do the full manual J AED calculation, you can comply that way, or you can use our simplified correlations. And to do that, you just put in the window areas on the 4 sides, and it tells you whether you pass and how close you are to the limit for that zone. Okay, for orientation having to do with the heating season or like losses from the windows in the winter, we use the same study buildings and put the windows at their U value limit for that representative city. And by the way, for this also the overhangs and the solar heat gain on the windows is as required by our other rules for that. That was the case in the cooling season protection study, and we carried that over into the net gain study as well. So here, though, instead of looking at the solstice or the equinox, we're looking at what the net gain is in the worst month. And you can see on the rainbow or zone chart there that in the hottest zones, you can't really avoid gain. It's just hot all the time. And in zones, say 1 through 3, you can't get net gain, and you probably don't want it, because there's solar protection measures in place or required for that. But for zones, for the colder zones, you could get net gain, and the orientation does make a difference. So the vertical scatter is being caused by the different orientations. So in the red box there on the upper right, those are the ones that have a net gain in the winter in the coldest month. But there are some exceptions like zone 4C and 5C and 8. Net gain was not available at any orientation under those other assumptions. So there's no requirement for those zones either. So this only applies to zones 4 through 7 except C. And once again, we did, so once again, we did regression fits, and this was mostly about, well, how much are the windows on the south and how much are on the north. So in the checklist then, it again gives you a pass-fail thing in the checklist. This is a summary of how the ranges, an informational summary of how the ranges fall and the dependence of all the window related requirements for overhang, solar heat gain, the net gain apply. And I think we're back to James to talk about thermal enclosure requirements.
Yep, thanks, Graham. Yep, so for the thermal enclosure, we've got broken out limits on a few different things. So the first thing that's kind of up in front that you should know when you're starting out a project is that we do have limits on the types of walls assemblies that are allowed. And this was mainly to encourage or prevent moisture risk and simplify the elimination of thermal bridges at the wall level. Thermal bridging elimination in general is another provision also in the checklist. And this is, again, moisture risk and energy saving provision here. And then we have opaque assembly R value requirements. And these are derived from our optimization study that we used for the performance path. But rather than running the regression formulas for minimizing heating and cooling demands and loads, we ran them to optimize and look at the effective things that affected the R values of the assemblies, which Graham will talk a little bit more about it in the next slide. Fenestration U values are a little bit different than the opaque assembly R values. These limits we set specifically on comfort. So we assumed a 9-foot window height and looking at the ASHRAE 99% design or drywall temperature. And we've basically set those U value requirements there. I do see one question that came up already in the chat, which I think I can answer real quick. But the limits on the allowed wall types are listed in the checklist. So I can summarize. Basically, we're looking at trying to get continuous exterior insulation on the walls. And the only types of double stud walls that are allowed are interior load bearing types. So that's kind of the high level of the wall types, but more details in the checklist. And then the last part we've got is there is an allowable total U value 8 times the area alternative path. And this is basically a trade-off. If you don't want to meet the component by component R values and U values, this is allowed to show that the effective U value of the whole building is meeting a reference case. Yeah, so this is maybe where I'll touch back to Graham quickly to summarize this for you.
All right, so yeah, as some of you might remember, to set our heating and cooling load performance targets, we did a life cycle cost optimization study on a bunch of study buildings and you know, fitted that data to, you know, functions of the climate factors. So we did the same thing here on the same study building data, just the single family ones. But instead of fitting the response of the overall heating and cooling loads, we fitted the R values for the components. And so the example shown here shows the sensitivities for the wall R value. So that turned out to be a function of the heating degree days and the design heating temperature. And up to a point, the electricity price, because that, you know, that influences the payback, which the life cycle calculation is sensitive to. So this correlation was pretty good, you know, R squared of 0.88, but there is some scatter, you know, it doesn't explain all the variation. So to make the fit conservative, we add that RMS error of 5.6, R 5.6 to the formula. So that's how we come up with the wall R value. And then there's separate fits done for the roof and for the floors.
Right. And then here's a quick summary page of informational data ranges for all of the component R values and U values, but keep in mind, this is just the ranges per climate zone. Each of these would actually be specific per climate location. So this is kind of high level to see the differences in these different locations. sorry, I had some sirens in the background. Going a little deeper now. So the checklist itself, this is a view of one of the options in the checklist for the opaque assembly filling out. Basically, the R value requirements are based on effective R values. So that means it includes the framing. And actually, we did have a specific question in the public comment period where they were asking, can we have a calculator of some kind to help determine effective R values? So this calculator is now built directly into the checklist. And basically you go through and you choose your wall type that you're trying to model. And you can have variable drop downs for the material types of the different assembly layers. You can modify the thicknesses to match up with the wall that you're proposing. And you can also have, putting in the correct framing type where applicable. And so this is basically telling you in this step 4 here of the checklist that the required R value is 40. And this particular wall is calculating the effective R value in R42.1. So it passes the requirement. Again, these vary by climate. This particular one is putting the climate in Chicago, Illinois. And the next thing we're going to talk about with this is section 6, the moisture and risk limitations, which are split into opaque assemblies and then fenestration requirements related to moisture and condensation risk. So here, our opaque assembly section is based on Phius's guidebook, Appendix B, where we have vapor control requirements for opaque assemblies. And again, the checklist has supporting calculations for this, which is built right into the same calculation where you're figuring out your effective R value. It also lists and gives you your information based on assembly type, what the hydrothermal and moisture guidelines are. And in this case, for this wall assembly, it needed to meet a sheathing to cavity R value ratio for this climate zone. And in this case, it is giving us a check mark, yes, that this is meeting because there's enough exterior insulation to prevent condensation risk. This is now the section 6 talking about fenestration. So previously it was opaque assemblies. So for fenestration, we want to make sure that you don't have condensation risk on the inside of your windows or your doors. And it's a really important piece of guidance that we want to provide and require rules about. But there are multiple rating systems out there, and basically all of them are optional. So Phius has given 5 different compliance paths available to show compliance with the fenestration condensation resistance stuff. And I'm going to just highlight quickly the first method is probably the easiest to check and make sure that you're passing. It doesn't require you to go to an external source like NFRC or something like that. And this is basically you put in what the general frame type you're proposing for your project is, and this will tell you based on that whether or not you're passing for your climate. But there are other options. You can infer your U value of your frame based on your window U value and your center of glass U value. You can refer to AAMA's condensation resistance factor if it's rated for that. NFRC 2020 condensation resistance, CR, only applies if it's the 2020 version from NFRC for this requirement here. Otherwise, CAN CSA A440 is also a temperature index you can refer to. And then the last one is this FRSI method, which is specific to Passive House, I think is where that comes from, the Passive House Institute in Germany, correct, Graham, right now?
It's also from the same ISO standard that sets the criterion. So the condensation resistance requirement is from an ISO standard, and that ends up being like a climate dependent thing. So yeah, they follow that in their window ratings.
Got it. Thank you.
And just a general note here, yeah, you'll get used to the formatting of this checklist. I hope the orange things are either fill-in fields or drop downs that you pick, and then the yeah, the blue things are calculated values, and the green things are the pass fails.
Yeah, if this was a fail, it would be red. Exactly. Next, I think we're heading back to you, Graham, with mechanical ventilation and mechanical systems.
Okay. All right. So what we have here is on the ventilation heat recovery, we have in the cold climates a requirement on winter performance, and that is mostly tied to a comfort principle again. So that's the level that's needed to deliver 60-degree F air at the average coldest month temperature. For the warmer climates, we have a requirement on the total recovery efficiency. So that's latent plus sensible. And that we basically, that requirement is basically created on a curve relative to what's available in the market. And you know, like deploying the requirements to the more humid zones. So that's a zone by zone type requirement, whereas the winter one is site by site. And there are a few zones in the middle, mixed zones, where where there's a limit or a requirement on both the winter SRE and the summer TRE. For the heating and cooling equipment efficiency, that is also zone by zone, and there's a lot of consolidation there. So basically in the coldest zones, it just has to be rated by NEEP, which is the Northeast Energy Efficiency Partners. Their rating system requires a test at 5F. And in the other zones, it's pretty much just Energy Star Most Efficient 2020. But there is a distinction made between the air source heat pumps and the ground source heat pumps because they use like different metrics. And so this is another sort of informational ranges table by zone. And so, yeah, you can see that, yeah, the zones that have both a winter and a summer ventilation performance requirement are 2, 3A, and 4A. Everything else just has either a winter or a summer. And yeah, the coldest, so basically the cold zones, except the C zones, have this NEEP requirement for the 5F test. Yeah, I think that's about all I need to say about that. Yeah, all the acronyms are defined down below there. And I think James is going to talk about this one.
Yep, I can touch base quick here. So this is an additional resource for that Phius has created, basically. So HVI, or the Home Ventilation Institute, has a whole mess of tested data on smaller ventilation units for typically single units, single dwelling unit, and single family homes. And so we've got a HVI Winter Ratings spreadsheet of all of the units that HVI has data on. And we basically adapted it a little bit further so that you can now sort this by putting in what you need for your minimum SRE, which again is the heating season efficiency that you need, the TRE, and then airflows and how much energy you want it to use in terms of watts per CFM. So this is kind of a useful document to download and play around with to see what's available for your area and what you need for your prescriptive path project if you're looking forward to doing that.
James, about how often does this list get updated?
This gets updated about twice a year, I would say. Yeah. The last time we updated was October of last year, and so we're about five and a half months out from the last time it was updated. But yeah, basically, if you see a new product out on the market that HVI has provided data for, and you're looking at the spreadsheet and you don't see it, reach out to Phius and we can arrange to do an update if you want to see the data for that new device if you see it on HVI's list that's not on this spreadsheet. Next section I'm going to take over here is section 9, which is the last one on our list here for lighting, appliances, and hot water. And this section is a little bit split. It's a little bit different than the others. So it's got two paths to meet the requirements for all of these pieces of information. Again, these are not passive building measures. This is overall energy use targeting that Graham talked about at the beginning of the presentation. So the first path is component by component based, meeting each individual either light fixture or appliance and water heater, meeting their component by component requirements. And the second path is performance trade-off. And this is an annual calculation with usage assumptions meeting or beating a reference case. So talking about component compliance, so for lighting, all the requirement we have in the checklist, which I'll talk about next, is based on Energy Star's top quartile for light fixtures. The electric efficiency for ventilators is based off of Zero Energy Ready Homes reference building limit. And the appliances in general, they vary by type. So whether it's a washing machine or a dryer or a dishwasher, that kind of stuff, it's either going to fall into Energy Star's most efficient 2020 list, Energy Star's top quartile, or it's an Energy Star median value, depending on what the appliance is. For water heating, we chose the Energy Star median uniform energy factor to qualify for a water heater on a component level. And if you're using a solar heat pump water heater, we use the Energy Star's top quartile to set that limit on the SEF. So for lighting specifically, it has basically three options for compliance with lighting. So you can take the component compliance path, which is all the fixtures, every single fixture needs to have an efficacy of greater than or equal to 83 lumens per watt. Or you can meet the lighting trade-off path by itself, which is the average efficacy of all the fixtures need to be greater than or equal to 83 lumens per watt. And then the last option is to use the performance trade-off path, which also includes appliances, hot water, and ventilation fan power, in addition to lighting. So the screenshot below right now that's currently on this page is the lighting trade-off calculation. So this is if you just wanted to do a trade-off for your lighting, this is kind of how you would go about doing it. You would say where your fixture is installed, how many fixtures they are, what the rated lumens are, and the rated wattage, and see if you're passing on average. So in this case, there's 3 fixtures in the bedroom, 2 in the bathroom, 4 in the living room. And right now, the bedroom and the living room are carrying the bathroom along for the ride because the bathroom's not as efficient as those other 2 spaces, but still on average, they are efficient enough to meet this 83 average efficacy. This is a screenshot of the performance trade-off in the checklist itself. So this is all of the pieces I just mentioned. So this includes lighting, this includes fresh air ventilation system, electric efficiency, and it includes appliances and water heating. So basically, if you're taking the trade-off path rather than the component by component compliance path, you basically need to fill out each of these sections with your specific fixtures and how well they performed, your specific appliances, what they've been rated at, and your particular water heater with what its actual rating is. And it gives you a holistic pass-fail up in the top right corner. In this case, it passes. So this is the performance trade-off path for the lighting, hot water, and appliances.
Yeah, just a comment here. So the things that are on this list are basically the things that have Energy Star ratings and would typically be installed by builders. If you're, say, not planning to install a dishwasher, you would just enter like quantity 0 in that column. And so, yeah, in that case, there would be no energy for the reference and no energy for the proposed either.
Right. And the last thing we'll talk about here is electrical vehicle readiness. So this is also a requirement for the prescriptive path, and it follows the same rules as the Phius CORE and/or source and/or Zero 2021 paths, which also have electrical vehicle ready requirements. So basically, for single-family homes, if a parking space is provided, you're going to need at least one EV ready space. And that's about it for the electric vehicle readiness. And then I will hand over to Graham for this last section, which is now in the summary of the updates from the public comment period.
Right. So as I think I mentioned at our last webinar on the overall 2021, almost half of the public comments that we got had to do with this prescriptive path. So we put a lot of work into this. Yeah, so in the scope, the limitation on square feet per bedrooms, we were advised that certain levels should be excluded from that if they're attics or basements that just don't have egress. And so yeah, we said okay. We've also noticed that there seems to be disagreement among different references as to what climate zones places are in. We've updated everything to ASHRAE 169 2020. Yeah, we totally overhauled the compactness rules that we put out for public comment, totally overhauled the fenestration orientation rules. We mentioned, the framing factors and vapor control rules in the initial launch, but that's now much better supported in the checklist workbook. And yeah, we somewhat simplified the window condensation resistance, and also revisited the ventilation heat recovery. What we had not done originally was look at what the combined effect is of the summer performance and winter performance requirements that we wanted to impose, to see whether there was anything left that satisfied them both. So we checked that and basically backed off the humidity recovery requirements a little bit so that it was still possible to find equipment. But we held the line on the 60 degree F in the winter, and the electrical efficiency. We also somewhat simplified the zone table for the heating and cooling equipment performance. And before, like when we first put it out, the appliance energy thing was only a performance trade-off path. We didn't have a device by device compliance path, so we added that.
Yep. Good summary. Thanks, Graham. And with that, I will talk a little bit about the design review process that we're envisioning for the prescriptive path versus the performance path. So in general, I'm picturing that it's going to be the same. It's going to work very, very similarly. We would still like projects to be submitted to Phius. They still need to submit drawing set and specifications like any normal project. But rather than reviewing an energy model or the WFI passive energy model, we will now be checking the Phius 2021 prescriptive checklist. And then the length of the review here is one that is a difference, right? Where If it's a checklist and you know exactly all of the specific requirements you need to meet, we are really picturing that this is going to be a one and done type review process. That's our hope, especially as project teams get more used to seeing this checklist. But so ideally, a single round of review. We're trying to get project teams in and out and start these buildings into construction as soon as possible. And then for the on-site review process, again, it is basically exactly the same. We are still getting inspections by a third party. So Phius Plus Rater is, again, integral, as Graham mentioned at the beginning. They still need to fill out the same quality assurance workbooks, the checklists, and provide photo documentation. They still need to be certified to Energy Star if it's required in your jurisdiction. You still need to be certified to Zero Energy Ready Homes if it's required in your jurisdiction. And you still need to meet those requirements, even if it's not a requirement to be certified in your jurisdiction. And then again, instead of reviewing the WFI passive energy model and aligning it, we are now just making sure, okay, did anything change in the checklist, and confirming that it was built as designed. And again, ideally a single round of review to go through the checklist and make sure everything aligns, and then certification is awarded at the end of that process.
Right. Yeah, I guess another comment on the checklist. So if you've looked at the Energy Star checklist or the Phius workbook, you'll know that a lot of the content is actually in the footnotes, and so a success factor for meeting the requirements is actually like understanding or like memorizing all the footnotes, and that's kind of similar to our checklist also. So there's a lot of detail in the footnotes. So yeah, once you've wrapped your head around all that, it should be pretty straightforward to comply.
And then talking about what's coming next. So we are working on, and we'll have an update to the certification guidebook, which will entail more than just the prescriptive path. It'll also include the new performance 2021 stuff. We are going to be working on updates to single family, multifamily quality assurance workbooks. And for people who have additional questions that we're not maybe going to be able to address this evening, for Phius members, please sign up and register for Graham's office hours next week, Tuesday. I think it's at this same time, 5 to 6 slot central. Yep. So yeah, look forward to that. And all of the checklist, the snapshot, and the standard setting document are all right now up on Phius's 2021 page. And this webinar, I think, will also be put up there as well as another kind of option. We had the 2021 launch recording last week. Tonight's the prescriptive launch. So that will also be available in the near future. And then in addition, we are going to try and create more resources for the prescriptive path in particular. I am envisioning having 5-minute webinar tutorials going through each section of the checklist, kind of piece by piece, to give people more familiarity with it. That's kind of my grand scheme picture for that, for more assistance. And yeah, anything else to add, Graham, before I give them their much needed code to end the webinar?
Nope, go for it.
And I will, so I know Lisa's been answering questions in the chat, which is great. The one thing about the chat that I don't think is helpful for when you review the webinar later is if a question was answered in the chat, probably can't actually see it. So I'm going to try and go back to the top and start looking through a couple of these questions and see if any seem super relevant and are worthy of a repeat out loud. There's one. Yeah, how is a 2-unit townhome treated? So how would you go through the certification process is that each individual unit would get its own certification. Phius does have discounted pricing for duplicate units, basically, if they're all in a row together in the exact same kind of thing happening over and over again. But yeah, they would each get individual certifications. And Lisa, yeah, if you chime in and you knew some that you, when you were answering and thought they were good ones, please.
I just have a more
let us
broad
know.
question as I'm answering these that I did not type out. But we had a question like, which specific types of residential do you think would go performance rather than prescriptive? Any thoughts on that?
Yeah, anything that's sort of out of scope or like, violates the scope limitations would have to go performance. If it's not satisfying compactness, or if they want a jacuzzi, yeah, there could be, or if it's just like very large, like a 6,000 square foot 2-bedroom or something like that, those would have to go performance.
Right, and in general, the performance path just allows for more flexibility, as all do,
Right.
relative to prescriptive. So,
Right, and as Graham noted when we were talking about the R values, the prescriptive path is meant to be more conservative. Like the goal is that we are ensuring that these projects are going to perform, even though it's going through this prescriptive path. So I would definitely imagine that if you went through the prescriptive path, if you took that exact same building, went through the performance path, you could probably back off the R values. You could probably, have more cost savings of, upfront envelope measures, I would guess. But the prescriptive path is meant to be quicker and easier to go through. That's the whole goal of it. So I think that's another
Right.
piece of it too, right?
Yeah, less soft cost, more hard cost, maybe. Yeah.
We've got a question about are wood stoves considered fireplaces? So this is kind of going back to an early one where basically we have no natural draft fireplaces are allowed. We only allow sealed combustion. And in this case, if it's a sealed combustion wood stove, that should be okay.
right, and we had a question tied along to that about the efficiency of the wood stove, if there's a regulation on that.
We
I
have
said-
not.
Yeah, I said no, so I hope
Step
that's
one.
right.
Yeah. Right. We have not developed that yet.
Right.
It doesn't help that they don't really have a universal rating system for efficiency of those types of units, I don't think.
Great.
Right. Yeah, we might end up just, putting a safety requirement on it or something like that. I think EPA or somebody has regulations on emissions.
Yep. We've got a pretty good question here about air tightness detailing. So does the Phius rater evaluate and approve these? And the question, or the answer here is that, so Phius, the intent is Phius will review the air tightness detail during pre-certification, similar to the existing program. And basically, yeah, that it should follow the same general requirements of providing documentation as the performance path.
Right. That's a design review, air tightness design review element that's the same as on the performance path.
We had a couple questions related to multi-unit things. So one was about duplexes that are one on top of the other. So those are out of scope. Only vertical partitions are allowed.
Right.
And then there was one more about electric vehicle ready requirements. And if, let's say, you have 20 townhouses, the EV ready requirement was 1 per dwelling unit. Is there really a 20 EV ready requirement? And I said we could maybe discuss this. In our performance program, we have kind of multifamily guidelines that have a percentage required based on parking spaces. I'm not sure it's something we've discussed, James or Graham. If we'd
We haven't
require
discussed this one. Yeah,
Yeah.
it was mostly if no parking was being provided, then they were exempt. But yeah,
Right.
we did not talk about this specifically. We could.
Yeah, so that could be something that we review. And then there was one more asked about if doing multiple units would be possible to perform a performance-based model, then do prescriptive paths for identical units. So if you're doing the performance-based for townhomes and things like that, it's a single certification for the entire enclosure. So like 10 townhomes would be one building certification, and you'd be meeting performance requirements for that building as a whole. So you would not flip halfway through to prescriptive, and there really wouldn't be any benefit to that. It'd probably actually be more expensive, at least from Phius's end, if you certified them individually than as one building. And there'd be more flexibility to keep it as a performance-based project.
I think we did have a rule for like, okay, you like identical units in the middle of the row.
Yeah,
Can
for
potentially
certification
share a prescriptive certification. So yeah, that would cut
Sure.
down the review overhead a bit.
Mhm.
There's a question, can we expand on Energy Star being required in your jurisdiction? Basically, I was referring to California and Alaska do not have Energy Star as a rating system there. California is starting to, they're getting more resident raters, but I was in general talking about, and Canada also is not a, it's not in the United States, so Energy Star doesn't really have a jurisdiction there. That's kind of what I was referring to answer
Right.
that question.
Yeah, you can't get any incentives for it, but yeah, we still use the requirements in our program.
Yeah. And there is a question, if a CPHC is leading the prescriptive process, do they still earn CE hours? I think the answer is yes. We haven't discussed this, but we would treat this exactly the same, I think, as a performance path project. You might not be doing the same level of energy, you're not doing any energy modeling, but we would still envision you're leading the process as making it a lot easier for the rest of the team, and still needing to make sure all the detailing and stuff is going to be good. So yes, same continuing education hours apply for prescriptive versus performance path.
Got one more minute. I have a question for you, Graham. Do you imagine Phius approved components? I'm only aware of the windows with Phius approval or certified data.
We have also a panelized construction system certification and a ventilator certification, although the ventilator program is right now sort of down for repairs. We're hoping to relaunch the ventilator program at the upcoming mechanical summit. And we've had internal discussions of some of having a program that that certifies products, that has like a wider scope, but maybe lower effort of certification for things that are like smaller components, say, or perhaps less directly related to passive measures and more about saving overall energy. But we have, so we might do that in the future, something broader of scope than just those three.
Last one, maybe before Jenny cuts me off, that I can maybe answer quickly too, is about cost for homeowners for the prescriptive path. Basically, yes, our goal was to reduce the cost. So right now, the cost is outlined on Phius's submit a project page. I won't spout off the specific numbers because I don't want to mess them up. So with that, yeah, check out the submit a project page. If you scroll down to the bottom, that's where the cost is outlined for prescriptive versus our regular program.
With that, I will cut everyone off and say thank you everyone for attending. And we're so glad you came, and thank you to presenters, James and Graham and Lisa. I know you all worked hard on this. If you are a Phius member, please do come to the office hours with Graham, where we will be talking about the prescriptive path and answering your previously submitted questions.
And anything else. So yeah, I wouldn't necessarily restrict it to the prescriptive path. So yeah.
So if you're not yet a member, there's still time to get in on this as well. So thank you everyone, and have a great night.